text-to-world connection. All right, so first we're going to watch a video.
Nina said as long as I was escaping, would I mind escaping to the market and picking up something for dinner? Sure, that was all I needed. A busy supermarket. I needed to drive, mellow out, get my mind off the wedding. But mellowing out was not in the cards.
Excuse me, sir. What are you doing?
I'll tell you what I'm doing. I want to buy 8 hot dogs and 8 hot dog buns to go with them. But no one sells 8 hot dog buns. They only sell 12 hot dog buns. So I end up paying for 4 buns I don't need. So I am removing the superfluous buns.
I'm sorry, sir, but you're going to have to pay for all 12 buns. They're not marked individually.
Yeah. You want to know why? Because some big shot over at the Wiener Company got together with some big shot over at the Bun Company and decided to rip off the American public. Because they think the American public is a bunch of trusting nitwits who'll pay for things they don't need rather than make a stink. Well, they're not ripping off this nitwit anymore because I'm not paying for one more thing I don't need. George Banks is saying no.
Who's George Banks?
Me! Why don't we just calm down now, sir? I'll tell you why we don't calm down. Because you're not excited. It takes 2 people for a we to calm down, doesn't it?
That I don't know, sir. I'm just the assistant manager of a supermarket. But I'll tell you this. If you don't pipe down and pay for those buns, I'm going to call the police.
Oh, right. Yeah. Yeah, right. That's right. Hey, right. Hey, come here. Come here. Come here.
All right, so use what you know about factor pairs to evaluate George Banks' mathematical thinking. Is his thinking accurate? What mathematical relationship is he missing? Number 2, how many hot dogs come in a pack? Or buns? 3, how many superfluous buns did George Banks remove from each package? How many packages did he do this to? Number 4, how many buns did he want to buy? Was his thinking correct? Did he end up with 24 hot dog buns? Was there a more logical way for him to do this? What was he missing? And what is the significance of the number 24? All right. We show you guys the real-life scenario involving least common multiples. We see this clip from Father of the Bride where George Banks is shopping for hot dogs and buns. George Banks identified 8 and 3 as a factor pair of 24, but overlooked the factor pair 12 and 2. A multiple of a whole number is the product of the number and any non-zero whole number. A multiple that is shared by 2 or more numbers is a common multiple. Multiples of 6 include 6, 12, 18, 24, and so on. Multiples of 14 include 14, 28, 42, and so on. The least of the common multiples of 2 or more numbers is the least common multiple, or LCM. The LCM of 6 and 14 is 42. You can see that 42 is in the list for both of these. There are 2 methods that can be used to find the LCM. Method 1. List the multiples of each number until you find the first one they have in common. Method 2. Write the prime factorization of each number. Multiply all factors together. Use common factors only once. In other words, use the highest exponent for a repeated factor. Find the least common multiple of 6 and 8. Method 1 would be to list the multiples out. Here we've listed out the multiples of 6, and here we've begun to list out the multiples of 8, and we can stop as soon as we have one in common, so 24. Here we have the prime factorization. So 6 is made up of 2 and 3, 8 is 2 times 2 times 2, so this becomes 2 to the third, and then we just take one number, whichever one is the highest exponent. So here we have 2 to the third, so we'll include that there, and over here we have a 3, so we'll include that there. 8 times 3 is 24. Find the least common multiple of 18 and 24. Multiples of 18 are as follows. The multiples of 24, so we can see 72 in common there, so 72 is the least common multiple. Using prime factorization, we have that 18 is 2 and 9, which is 2 and 3 and 3, so 2 times 3 squared. 24 breaks down to 3 times 2 times 2 times 2. Collect those into 2 to the third times 3. Now we have a 2 and a 3 down here, so we pick the ones with the largest exponents. So we'll pick 2 to the third and 3 to the second. And when you multiply those together, you get 72. Here's an interactive website that uses a Venn diagram to help find the GCF and LCM for extra practice. Alright, so here we have factor trees. So let's find the prime factorization of two numbers. Alright, so 48 is 12 times 4. Check. Cool. Alright, so 12 is 3 times 4. And 4 is 2 times 2. Cool, and this 4 is also 2 times 2. Nice! And then it lists out what the prime factorization of 48 is. If we get it wrong, say we put 3 times 4, it will say a little error buzzer. 4 times 4, 2 times 2, 2 times 2. Get the greatest common factor. Yes, please. Alright, so 48 and 16. Common factors. 2, 2, 2, and 2, and this 3 is over here still. So what is the greatest common factor of 48 and 16? Well, it's 2 times 2 times 2 times 2, which is 16. Cool. Now let's find the least common multiple. Alright, so that would be 3 times 2 to the 4th power, which is 48.